Bright Tuty. Every student matters.
Now, let us look at this question here. Fill in the blanks using the correct word given in the brackets. So, all the circles are congruent or similar. All the circles cannot be congruent, right? The circle can be of 1 centimeter radius, 5 centimeter radius. Let us say this is 1 centimeter, this is 5 centimeter. So, their size is different, right? And these are two circles. So, the shape is same, but the size is different. So, all the circles are necessarily similar, but may or may not be congruent depending on the radii of the circles, right? If I look at the second part here, all squares are, now squares can also be of different sizes, whereas the shape is same, right? The shape is a square shape, but the size is different. So, they may or may not be congruent, but they are necessarily similar. When will they be congruent? When the side length is also equal, okay, then the squares will be congruent, but all the squares are not congruent, right? All triangles are similar, all isosceles triangles are similar, or all equilateral triangles are similar. In case of isosceles triangles, now what can happen is, all equilateral triangles will have all the angles equal, that is 60, 60, 60. Now, the size may be bigger or smaller, 60, 60, 60, right? But in case of isosceles triangles, you may have 45, 45, 90 triangle, right? Another triangle that is isosceles may be, let us say 50, 50 and 80 degrees. Now, this triangle is isosceles, this triangle is also isosceles, but are they similar? They are not. Why? Because this angle, all the angles are different in these two triangles, but in equilateral triangles, all the angles will always be same because they are 60 degrees each, right? So, we can say all the equilateral triangles are similar. Can isosceles triangles be similar? Yes, they may be similar if all the angles are same, but not all the isosceles triangles are similar, right? If let us say we have got two isosceles triangles having same angles, then these two are similar, right? But not all the isosceles triangles, because isosceles triangle may have these angles, or it may have these angles, or any other combination of angles. But in equilateral, all the angles will be 60 degrees. I hope this concept is clear. Two polygons of the same number of sides are similar only when their corresponding angles are equal and their corresponding sides are proportional. This we have studied in the introduction, right? So, equal will come in this first blank and proportional in this second blank, right? So, the corresponding angles should be equal and the corresponding sides, mark the word corresponding, corresponding sides should be proportional. How do you look for corresponding sides or corresponding angles? Let us say you look at the angles first. So, the equal angles should have this, the opposite side to the equal angles should be proportional. That is how you look for corresponding sides. Now, give two different examples of pair of similar figures. So, we can take first examples as circles, second example may be of squares, right. So, these two are the examples of similar figures, okay. For non-similar figures, we can take two entirely different geometrical shapes. For example, a circle cannot be similar to a polygon or a quadrilateral. So, these two are non-similar. Another example that we can take here is For example, let us take two same categories, for example, quadrilaterals. Let us take one quadrilateral as this, second quadrilateral as this one. In this, the sides, let us say 1, 3, 4 and let us take it as 3, okay, and in this let us take the sides as 2, 2, 2, 2, right. So, these two quadrilaterals are not similar to each other, right, because I have taken the ratio of sides in such a manner that they cannot be equal, right. I am not concerned about the angles as of now, because if any of the conditions is not met in these polygons, out of those 6 conditions, that all the angles should be equal and all the corresponding sides should be proportional. So, if any of the conditions is not met, these figures will not be similar figures, right. So, these are two examples for non-similar figures, okay. Now, you tell me whether these quadrilaterals are similar or not. Now, what are the things we are looking for? First, the angles. By the first look, we can say that these angles are different, because in this figure all the angles are 90 degrees, but in this figure angles are not given, but certainly these are not 90 degree angles, right. If these were 90 degree angles, if these were 90 degree angles, he would have given this kind of notation or this kind of symbol here. So, in this angles are different, hence we can say these are non-similar figures. Or the second thing, if the angles were equal, then we would have looked at the correspondence or the proportionality of corresponding sides. Now, in these two figures, the sides are proportional, yes, because if you multiply this side by 2, you will obtain this side. Similarly, this by 2 will give you this side, and this by 2 will give you this side and this side, because all the sides are double in this. So, yes, we are scaling up these figures, but not equally from all sides, right. We are not maintaining the shape, we are not maintaining the angles here, right. This angle is not same as this angle, hence these figures are not similar. So, not similar because the angles are not equal, right. So, this was about the introduction of this chapter. Now, in the next exercise, we will discuss about an important theorem, that is basic proportionality theorem. It is also known as Thales theorem, and we will also apply that theorem and solve some of the questions in the next exercise, right. Thank you.